fra Tor da, så skal vi litt sånne internasjonale vibes nå. Vi får Italia på scenen, vi får temperament, vi får pasjon, vi får romantikk.
Oh, yeah.
Ja, innenfor feltet teknisk gjeld. Og jeg kunne ha stått der og prøvd å sagt hva det betyr, for jeg lærte tidligere i dag. Men det er så mye bedre at Antonio får lov til å forklare det til oss. Are you ready, sir?
Yes.
Ja, han forstår norsk, altså, men han tar det på engelsk. Vær så god, the stage is yours, Antonio. Kan jeg bare legge til en ting? Vent da. Tilfra han ikke ser selv, så er han professor da. På Universitetet i Oslo. Ja.
Takk, det var vi.
Ja. Antonio!
Hi everyone. Thanks, Axel. I will try to make it a bit more romantic, but not too much. True. I understand that when you hear Italian and that on the same phrase, it doesn't sound that reassuring, but I promise you it's not what it looks like. So, what has this to do with AI? I will explain right now. Like Axel said, I'm Italian. I've been in Scandinavia for quite a few years. I've been a software developer many years ago. I did a PhD and I did some research, and then I went back to doing consultancy to some large companies in Sweden, and then I came back in Norway to do some more research. So I've been always a little bit in between, like trying to do research, but also trying to make sense of something that actually, you need to apply in practice every day. That's why I ended up studying technical debt. So how many of you know what technical debt is, have heard about it? Well, okay, yeah, that's good. That's very good. How many of you have actually is involved in managing technical debt every day? Many less. Okay, so I will introduce very quickly what technical debt is, because I think it's important for everyone is on the same page. So this is what technical debt is to me. You have like some wonderful feature in your product. It's like brilliant, it works well, every user loves it, but you have like always like a big risk, like on the back of the software, that something sooner or later is going to happen, because there is like an awful design behind it. It could be that like 50 years ago this was great design, but now maybe it's not anymore. Or maybe we just had to, put together some tape and stuff. What's the problem with this? Is that, okay, this is all those suboptimal issues that we have that we don't feel they are really impacting our value that we deliver to the customers. But if you have to actually put like a dishwasher here, not dishwasher, a washing machine here, I always mix those two up. How would you do that, right? It's going to be like a big mess. So we don't see the direct impact right away, but when we get to feel the impact, then it's going to really harm us. So that is the problem with technical debt. It's those all suboptimal decisions that we don't see, or we sort of forgot about them, but they are going to come back to harm us. Now, I'm just the reason why I'm here is because we have this project that is funded by the Research Council together with Knowit and Visma and Aqua Group, which is called Data-Driven Continuous Management of Technical Debt, and something else. But why is this important? Why now? Why technical debt and why AI? Well, let me go through a little bit of the challenges that, why do we want to study technical debt and why do we want to do something about it? So first of all, what happened recently has been that everything has been growing. Like I think someone has mentioned it also. So company size and complexity is growing. Software complexity itself is growing. And this whole thing means that the risk of having more technical debt is raising. At the same time, we try to be as fast as possible to deliver value. This means that we have less and less time to actually check. We cannot actually check what's happening every day with our technical debt. And so we need to have like real-time insights about what technical debt we have, what are we accumulating every day. When we push out software, we get a new debt every day. So how do we know that? How can we make sure that we are always up to date and we don't take too much risk with respect to what we can? That's why we need something to be very data-driven. and try to make sense of all the data that is already there, because there is a lot of data that we have available. The problem is that who is going to go through them to understand our technical debt? So that's why we have all we are starting using all these latest trends in AI, such as the large language models. Large language models are basically ChatGPT is a large language model. A lot of people have already talked about them, so I don't have to do that. Thank you for that. But also there are newer and newer way of training new models. For example, this transformers-based. It's very fast. So basically, that means that you can throw at it a lot of data, and that is going to learn very fast, much faster than what we can do in some cases. So what has this to do with software development and with technical debt in particular? So if you look at technical debt to find issues in our code, a lot of tools, they just look at the code. But a lot of things that we know that we should take in consideration when analyzing our code, it's in the context. Like I think the previous presentation said that in a bit less positive way, but actually context can be very important to understand what's happening, right? That's why natural language, we have a lot of documents with natural language, so we can use that to understand better where our technical debt is and what we have. So this is a little bit, I'm going to go through like 2 or 3 examples about what we are going to do, we are doing at this time in this project, trying to make it as simple as possible. The first thing we did was, okay, let's just try to go, I guess you are familiar with GitHub. It's like all these, open source projects, like hundreds or thousands of open source projects from several. It could be also, Visual Studio has some open source and that kind of stuff. So it's not only like toy projects, but there are a lot of real projects. So we went through all of them, from not all of them, but the best ones. And then basically we found that there were like 50,000 technical debt issues, which developers themselves had tagged as, oh, this is technical debt. And I'm talking about issue trackers. Like you probably use Jira or Trello or here and there. So sometimes developers they had like a story and they say, okay, this is technical debt. We have to fix this. Okay, and then we basically train a model based on all those issues that we found. And then we said, okay, now we have a model that it's trained only on technical debt issue. Is it able to recognize technical debt in my project? So we throw a couple of projects at that, and it didn't work that well, to be fair. Yeah, you were waiting, oh, it was awesome. No, it didn't work that well. It actually varied quite a lot. But, and that's the nice thing I'm going to say is, then we said, okay, but what if I give you, model, a little bit of my data from my project? Would you become a bit better? And that's actually what happened. So we gave like a few issues from my project and said, okay, now learn a bit about my context and try to understand technical debt on the rest of it. And that performed much, much better. So that means that we were able to recognize technical debt issues like on the 80–90% of the cases. So that means that you have a lot of interest application from this, because if you, for example, if you have tagged technical debt, but maybe you're not being so consistent, this could actually help to say, okay, look, this is what I've done. Please tag all the rest of my technical debt. Find all my rest of the technical debt in my project. Or other things like you actually don't know you are talking about technical debt, in that you're just discussing with your colleagues about some issues that there is. Basically, you could say, our model could say, oh, wait, you are talking about technical debt. You know, there is this fantastic other project where this technical debt was solved this and that way. So this could be like quite interesting. Just to make an example about what, so you have like issues where people, describe an issue or talk about an issue, and you basically put a label on that. This can be interesting. For example, this is actually a real project where you can see So the gray one, the black one are the normal issues, like, you're talking about features and other things. The gray issues are people talking about technical debt. So you can see when technical debt has been discussed the most. It was quite interesting. You have a lot of use cases for trying to use this in one way. My time is almost up, but the other thing that it's important to do is trying to work. A lot of people said, okay, we have large language models, but are they reliable? Well, not always. But basically what we're trying to do is to train our large language model by using reliable sources. So it's a little bit like you have a student and you give him like a book to learn, okay, now you know how to talk, now please study these important things. And I think my time is up, so I will stop here. I have another example with some visualization. We also look into this, but so that's, I think, that's what I would like to present today. Thank you.